While f of x is a function, f prime of x, which has nothing to do with prime numbers, denotes the derivative of the function f of x, whereas f double prime of x denotes the second derivative of f of x, and f triple prime of x denotes the third derivative of f of x, and so on.
But to understand how to interpret the graphs of derivatives and relate them to each other, the most important factors are f of x, its first derivative, or its second derivative. F prime of x is the rate of change of f of x, while f double prime, the rate of change of the rate of change of f of x. F prime of x is the concavity of the original f of x.
Given when f prime of x is positive, f of x is increasing, and when f prime of x is negative, f of x is decreasing, since f prime of x is the rate of change of f of x. Also, when f double prime of x is positive, it means that f of x is concave up, with f prime of x, which is the slope, increasing. And when f double prime of x is negative, that means the concavity of f of x is concave down.
Now if we take a more complex function, we can teach you more rules in determining what a function's first and second derivatives look like at certain points. When f prime of x is equal to 0, then that is a critical point on f of x. And if f prime of x goes from positive to negative, then that means that f of x is a maximum on the f of x graph. And when f prime of x goes from negative to positive, then that means that f of x is a minimum on the f of x graph. If f double prime of x is positive and non-zero when f prime of x is 0, then it is a minimum. But if f double prime of x is negative and non-zero when f prime of x is 0, then it is a maximum.
When f double prime of x is 0, then there is a point of inflection for that x on f of x. If f double prime of x goes from positive to negative, then that means that it changes from concave up to concave down. And if it goes from negative to positive, then it's going from concave down to concave up.
Understanding graphs and what their derivatives look like can also help in other fields like physics, with one example being position, velocity, and acceleration, where the derivative of the position graph is the velocity time graph, and the second derivative of position, or the first derivative of velocity, being the acceleration time graph, and the derivative of the latter being the same.
Here is an example of using the graphs of derivatives in position, velocity, and acceleration. Let's say that x of t equals x cubed times e to the negative x under the conditions that t is greater than 0. This is the position versus time. In this scenario, x prime of t, or v of t, where the velocity time graph would be equal to negative x cubed times e to the negative xth power plus 3x squared times e to the negative xth power.
The derivative of this can be used to determine acceleration, and the integral between the 2 points of time represents the displacement on that interval. The integral of acceleration can similarly find the total change in velocity on an interval. The derivative of acceleration can be used to find jerk, the rate of change in acceleration, and so on. The integral of jerk would be equal to the total change in acceleration on an interval.
Of course, just to look at the visual characteristics of these functions can give critical information about an object's position, velocity, and acceleration, and the changes in accumulation of those values. For instance, even if we didn't know the exact function that a of t was defined as, if we saw that its value was above 0 at a particular point, of time, we would know that the velocity was increasing at that point in time. And similarly, if we saw that the area bounded by v of t and the x-axis in a particular interval was positive, we would know that the displacement on that interval is positive. And the same thing can be said about the derivative of acceleration, the second derivatives, and really anything that's related to position, velocity, and acceleration.
We are John, Sai, and Joaquin, and we'd like to thank you for watching our final project for AP Calculus AB.